Hey everyone, today we're gonna discuss about organic chemistry. So let's start the lecture. Definition of hydrocarbons. Hydrocarbons are organic compounds made up of only carbon and hydrogen atoms. They are the simplest organic compounds and they form the basis of all other organic compounds. There are two types of hydrocarbons: saturated hydrocarbons and unsaturated hydrocarbons. In saturated hydrocarbons, we only have single covalent bonds between the carbon atoms, while in unsaturated hydrocarbons, we have double or triple carbon atoms. The general formula of saturated hydrocarbons is CnH2n plus 2, where n is equal to the number of carbon atoms. The saturated hydrocarbons can also be called alkanes or paraffins. What are the properties of saturated hydrocarbons? They are less reactive, which means that they are chemically stable. They undergo substitution reactions and they burn in oxygen to form carbon dioxide and H2O. Examples of saturated hydrocarbons include methane, ethane, propane, butane, etc. Now, unsaturated hydrocarbons form double bonds or triple bonds between the carbon atoms. They are more reactive than the saturated hydrocarbons. The first type of hydrocarbon is alkene. It is a hydrocarbon with at least one double bond. This means that it is a type of saturated hydrocarbon. The general formula for alkene is CnH2n. Alkenes undergo addition reactions and examples include eth, propene, butene, etc. Basically, eth, prop, but, meth, these are the types of stem words. Now let's move on to alkynes. Alkynes are the hydrocarbons with at least one triple bond. Their general formula is CnH2n minus 2. They are highly reactive hydrocarbons and examples include ethyne, propyne, butane, etc. Basically, we have the normal stem words that come from 1 to 12 and then we just change the suffix. Like if we have alkanes, we will change the suffix to ane. That means we will have methane, ethane, butane, propane. If we have alkenes, then the suffix will be changed to ene. And if we have alkynes, then the suffix will be changed to yne. Now I have a comparison table for you all. So the bonds between carbons, if we have a single bond between carbon, then that is known as a saturated hydrocarbon or alkane. But if you have the bonds between carbons as double or triple, they are called as unsaturated, which means they are alkenes or alkynes. The general formula of saturated or alkanes is CnH2n plus 2, while in unsaturated hydrocarbons we have alkenes and alkynes. Their general formula is CnH2n and CnH2n minus 2. The reactivity of alkanes is less, while the unsaturated or alkene alkyne have much more chemical reaction. Now, in saturated hydrocarbons, substitution occurs, while in unsaturated, addition occurs. And I've also given some examples like CH4. As you can see, the number of carbon atoms is 1, so this means that this will be an example of methane. If we have 2 carbons, then that means that this is ethane. Same as for alkenes and alkynes, we have 2 carbon atoms, then this means that this is ethene, not ethane. Why? Because the suffix is being changed. Now, key point to remember is that saturated means single bonds, and single bonds are stable and less reactive, while unsaturated means double or triple bonds and they are highly reactive and they perform addition reactions instead of substitution reactions. Thank you. Hey everyone, today we are going to discuss about the chemical diversity of organic compounds. So the first chemical diversity is known as kination. Kination is the ability of carbon atoms to join with one another to form long chains and rings, and that ability is known as kination. Now, the reason for this is that carbon can form strong covalent bonds with other carbon atoms because of the small size and tetravalency. Now, the types of structures formed between carbon, it is straight chains, the branch chains, and the rings. Rings are also known as cyclostructures. I've also given some examples. For straight chains, you can see that we have butane. Butane is an example of a straight chain. Why? Because we have four carbon atoms being joined together. Same as for branch chains, we have isobutane. This is basically an isomerism of butane. You will learn as we go down the topic. And then we have a cyclohexane. Cyclo or cycle basically stands for the rings. They are the cyclic structures. Now, what is the importance of chenation? Chenation is responsible for the large number of organic compounds, and it makes possible the formation of simple molecules like methane and complex molecules like proteins, DNA, carbohydrates, etc. Isomerism. Isomerism is the phenomenon in which the compounds have the same molecular formula but they will have a different structural formula. It is known as isomerism. Now, what is the importance of isomerism? Isomerism explains the existence of a large number of organic compounds with different properties, and even though they have the same molecular formula. In summary, we learned that chenation are self-linking properties of carbon-forming chains, rings, and branches. Isomerism is the phenomenon where we have the same formula but the different structures and the different properties. Both chenation and isomerism are known as chemical diversities of organic compounds, and they are the key reasons for the diversity of them. Hey everyone, today we're going to discuss about alcohols from Organic Chemistry Unit 9th. So let's discuss what are alcohols. They are basically organic compounds in which a hydroxyl group, also called OH or hydroxide, is attached to a saturated carbon atom. In our previous lectures, we learned about saturated hydrocarbons and unsaturated hydrocarbons. We basically learned that saturated hydrocarbons are those hydrocarbons which form a single covalent bond, while the unsaturated hydrocarbons form double or triple covalent bonds. So when you have saturated hydrocarbons and they are attached with a hydroxyl group, so basically they are called alcohols. The general formula of alcohol is R, where R stands for the alkyl group and OH is the hydroxyl group. The classification: we have three types of alcohols. The first is primary alcohols, the second is secondary alcohols, and the third is tertiary alcohols. So the primary alcohols are where the OH group is attached to a carbon linked with one alkyl group, while secondary alcohols are the same, but instead of one alkyl group you will have two, and in tertiary you will have three. Now let's move on to the physical properties of alcohols. They are the lower members and they are soluble in water due to their hydrogen bonding. Their boiling point increases with their molecular mass and they show hydrogen bonding. What is the chemical properties of alcohols? They can form combustion, oxidation, esterification, and dehydration. Hey there everyone, today we're gonna discuss a new type of organic compound which is haloalkanes or called alkyl halides. Haloalkanes, also called as alkyl halides, are those organic compounds in which one or more hydrogen atoms of an alkane are replaced by halogen atoms. Examples of halogens include fluorine, chlorine, bromine, or iodine, and the halogens are denoted by the symbol X. The general formula of haloalkanes is R forming a covalent bond with X, R forming a covalent bond with X, where R is the alkyl group and the X is the halogen atom. So the classifications, we have three types of haloalkanes. First is primary, the second is secondary, and the third is tertiary. In the primary haloalkanes, the halogen is attached with one alkyl group. In the secondary, the halogen is attached to two alkyl groups. And in the tertiary, we have the halogen attached with three alkyl groups. Now let's discuss the physical properties. They are generally insoluble in water but soluble in organic solvents. Their boiling point increases with their molecular mass and it decreases with halogen electronegativity. What are the chemical properties of haloalkanes? Nucleophilic substitution reactions, elimination reactions to form alkenes, and the reactions with metal. Ethers are the organic compounds in which two alkyl or aryl groups are bonded to the same oxygen atom. The general formula of ethers is R forming a covalent bond with oxygen and oxygen then forming another covalent bond with R, where R and R naught are the alkyl and aryl groups. The nomenclature of ethers. The groups attached to oxygen are named in alphabetical order followed by the word ether. For example, I have oxygen and with oxygen we have an alkyl group which is hexyl and in the aryl group we have heptyl. So what will be the name of this organic compound? So this will be named hexyl heptyl ether. In the end ether will come. Why? Because we have oxygen bonded with two alkyl aryl groups. The physical properties of ethers, they are generally colorless and volatile liquids. They are generally colorless and volatile liquids. They are slightly soluble in water but soluble in organic solvents. They have relatively low boiling points compared to the alcohols. What are their uses? They are used as solvents in laboratories and industries. Diethyl. Diethyl means that we have two diatomic molecules of ethyl. Diethyl ether is used as an anesthetic, though it is less common today. Ether is also used in perfumes and as a starting material in chemical synthesis. Aldehydes. Introduction. Aldehydes are a group of organic compounds that contain the covalent bond CHO. Covalent bond CHO stands for the aldehyde group, where C stands for carbon, H stands for hydrogen, and O stands for oxygen. The general formula of aldehydes is R covalent bond CHO, where R can be hydrogen or an alkyl group. An aldehyde has a carbonyl group, which means that carbon will form two covalent bonds with oxygen attached to at least one hydrogen atom. An example is of formaldehyde or acetaldehyde. As you can see, instead of the R, we have placed hydrogen forming a covalent bond with the aldehyde group. Same as for the second, we have formed CH3 with the CHO, which basically stands for the aldehyde group. The nomenclature of aldehydes, according to the IUPAC system, the suffix Al will be added to the name of the parent hydrocarbon. For example, the formula is R covalent bond CHO. So if R is hydrogen, and this means that the number of carbon atoms will be 1. So our stem word will be meth and the ending will be with Al. So methanol, ethanol. According to common names, it is derived from the corresponding carboxylic acids. Examples include formaldehyde and acetaldehyde. Sources of aldehydes, they perform oxidation of primary alcohols like ethanol can be converted to ethanol, the partial oxidation of hydrocarbons. Some are naturally found in essential oils, fruits and plants. Physical properties of aldehydes. Most lower aldehydes are colorless gases or liquids with a sharp smell. Higher aldehydes are solid at their room temperature and they are polar compounds due to their carbonyl group. They are also soluble in water. They are also soluble in water, while the higher members are soluble in organic solvents. The chemical properties of aldehydes, they can perform oxidation. They are easily oxidized to carboxylic acids. Reduction can also be occurred, which is when aldehydes can be reduced back to primary alcohols. Addition reactions, they react with hydrogen cyanide, sodium bisulfate, and other nucleophiles at the carbonyl group. Polymerization, formaldehyde undergoes polymerization to form plastics and resins.